2015, Paper 1, Question 1, Sequences and Series. So Mary is throwing a ball and it's been thrown onto a level ground which has a height of 2 metres. So in other words, it's dropped from 2 metres onto a ground. So every time it hits the ground, it bounces back to 3/4 of the height of the previous bounce as shown in the diagram. So in other words, the ball is getting lower in its height each time. So it's losing energy each time until it eventually comes to a stop. So we're given a table that we have to complete here showing the maximum height, but it has to be in fraction form. And we're to do it for the first 4 bounces. So the first one is filled in for us. In other words, as it's dropped, it has a height of 2 metres that it's dropped from. So for the first bounce, it's going to be 3/4 of the previous one. So in other words, 3/4 of 2 is going to be 3/2 metres. Our second bounce is 3/4 of the previous one. So in other words, 3/4 of 3/2, which is 9/8. Again, that's metres. Our third bounce is 3/4 of the previous. So again, 3/4 of 9/8, which is 27/32. And then the fourth bounce, again, 3/4 of the previous one. So 3/4 of 27/32 gives us 81/128 metres. So we just simply fill those into our table then. But again, I would show all my work where possible, because if we just happen to make one small mistake when filling in these tables, we could lose a lot of marks. So make sure you're showing your work to get the maximum marks you possibly can. And it has to be in fraction form. So there was 5 marks for filling that in. And it was 0, 2, 4, 5. And again, had to be in fractions. So in B, we have to find in metres the total distance vertically, so that means both up and down, that the ball has travelled when it hits the ground for the 5th time. And we have to again give our answer in fraction form. So if we're looking at hitting the ground the first time, well, that means that the total distance on its first hit is going to be 2 metres, so it's dropped from 2 metres. Then it's going to go up 3/2 metres and down 3/2 metres. That's going to be 2 times 3/2. But it also goes up and down 9/8, up and down 27/32, and up and down 81/128. So in other words, we can actually multiply 2 by the sum of all of those heights because they're going up and down. And that gives us then a total vertical distance, in fraction form of 653/64 metres. So there was 10 marks for that, so a really handy 10 marks that. So 4, 8 and 10 marks going for that, and again starring that because it had to be in fraction form. Okay, so C. So we're asked, if the ball continues to bounce indefinitely, find in metres the total vertical distance it would travel. So again, if we set up the equation, well, that's going to be 2 plus 2 times 3/2, 9/8, 27/32, 81/128, and then that continues indefinitely. So what we can see here is inside the brackets is that we're going to have a geometric series where we're multiplying each term by 3/2, and it's a sum to infinity then inside the brackets. So we look at the first term, so T1, T2, T3, T4, where A is 3/2, And our common ratio is term 2 divided by term 1. So in other words, 9 over 8 divided by 3 over 2 gives us a common ratio of 3 over 4. So our sum to infinity is a over 1 minus or, which again can be found on page 20 in our maths tables. So we can see that here on the bottom. So geometric. So subbing in, we have a, which is 3 over 2, divided by 1 minus 3 over 4. So 3 over 2 divided by a quarter gives us sum to infinity of 6. So therefore our total vertical distance is going to be equal to 2 plus 2 times our sum to infinity, which is 6. And therefore that gives us a total distance of 14 metres. And that's the total vertical distance. It's a nice little question, that. So we had 10 marks, and that was going to be 0, 4, 8 and 10.